Welcome back to chemical bonding. I'm going to show you that I can prove, or at least support, that you can use this NAS method to draw Lewis structures no matter what the compound is. So we're going to look at some of these exceptions, and the odd electron species, the free radicals, we're not really getting into those, but they do have incomplete octets. Okay, so they'll have fewer than 8 electrons around them. You can't write legitimate Lewis structures for those because they won't really meet the octet rule. Now, some others, and these are like these. Like that's why you take antioxidants, because these are actually molecules that cause damage to tissue and things like that. That's kind of beyond us in this, so we're not going to really talk about those that much. What we will do is talk about the exceptions to the octet rule that are either less than an octet, and these are typically the small elements: lithium, beryllium, and boron. And boron is the main one for the molecular compounds. And then it could also be an expanded octet where you have more than 8 electrons around an atom. Remember though, it's going to be the central atom, because only the central atom can violate. Okay? All right. So the best way to look at this is to do one. All right, so let's look at Xenon Difluoride. Okay, so xenon doesn't normally react with things, so you have to do some special stuff to it. But the xenon is obviously going to be less electronegative than the fluorine, so it's going to go in the middle. So our structure will look something like that. Okay, that's our skeleton. And then I'm going to do an NASB for it. And so a 1, 2, 3, so 8 times 3 is 24. Available, I have 7 times 2 because both fluorines, and then plus 8. And that gives me 22. So that says they're going to share 2, and there would be 1 bond. And this is where I was telling you, when I see something like this, little sirens go off in my head, because I know this is going to be a violator. Because I've got 2 things to connect, and the bond tells me I can only have 1 bond. So I know that I'm going to disregard that bond because I know it's going to violate the octet rule automatically. So I'm going to go back to my available electrons, and I'm going to count for the ones I've done so far. Now remember, I can't double bond these. So because it's not a pecan, okay? It's not a pecan, so you can't double bond them. So I've got 22 minus 4 electrons from the bonds, which gives me, let's see, 18. I do it in my head. All right, and then the next rule is I complete the terminal. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's minus 12. And so that leaves me with 6. Now I've got 6 electrons left over, and I'm going to do them in pairs, and I can only put them on the central atom. So I'm going to put 1, 2, 3, 4, 5, 6. And that it violates the octet rule because it's an expanded octet, more than 8. For that xenon. And that's not a shocker, right? Why? Because it's not supposed to react. Okay, and so obviously it's going to do some kind of interesting things. So I've got one that's very similar to that for you to use also, but before I leave this, I wanted to show you an incomplete octet. Okay, so an incomplete octet usually is going to have boron in it. Okay, so I'm gonna do BF3. Okay, BF3. All right, so boron is not as electronegative as fluorine, so I'm going to put it like that for my skeleton. And I'm going to do my NASB. And I have 1, 2, 3, 4. So 8 times 4 is 32. And available, I have 7 times 3. And then boron has 5, I want to say. Sorry, I'm doing this one off the top of my head, and I just had like a mental breakdown. So boron is atomic number 5. So it's 5. I was right. See, I should trust myself. All right, so 5. Okay, so 7, 14, 21, so that's 26. So that's 6. And so it says 6 divided by 2 is 3 bonds. All right, and that's what I'm showing. So I'm going back to my 26. So I'm thinking, okay, well, I'm going to have extras on the boron, right? That's why you do this and go through the steps, because sometimes it'll trick you. All right, so I've got 2, 4, 6. That leaves me 20. Right? Is that right? So, wait. Let me make sure this number's right. 7, 14, 21, 26, 8, 16, 24, 32. So there's 3 bonds. Okay. So 2, 4, 6. All right. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Minus 18 is 2. And so that would say that we do it on there. But okay, it's not in group 5, it's in group 3. My mistake. So that should be 24. That should be 8. Right? And so that should say 4. All right. Sorry about that. All right, so that's what happens when you do something off the top of your head on a video, right? Okay, so that should be 24, and then that should be 18. And so when I put all the electrons on there, I've used them all up. So I see that boron has less than an octet. So this is one that is an incomplete, because once I run out of electrons, I have to stop. Okay, I have to stop. So that's why boron violates the octet rule by having an incomplete octet. Sorry about the fumbling around. Okay, and so then I gave you some practice ones. I do want to help you a little bit with this phosphoric acid. So your skeleton is going to be like, you haven't seen one like this, so I'm going to help you out just a tad. Okay, so that's your skeleton, so then you can work it out from there. And that is the octet rule and Lewis structures on your violators.